Mars's distinctive rust-colored appearance has earned it the moniker the Red Planet across cultures and throughout history. This celestial neighbor stands out in our night sky with its characteristic reddish hue that has captured human imagination for millennia. The nickname isn't merely poetic. It's rooted in observable scientific reality that continues to provide researchers with valuable insights into Mars's complex geological history. Recent discoveries have even challenged long-held assumptions about exactly what gives Mars its iconic color, potentially reshaping our understanding of the planet's past environmental conditions. The striking rusty hue that distinguishes Mars is primarily attributed to iron oxide, essentially rust, that blankets the planet's surface. This iron-rich dust and rock covering, known as regolith, gives Mars its characteristic red-orange tint, visible from Earth and space. The presence of iron oxide is so pervasive across the planet that it dominates our perception of Mars, making it instantly recognizable among the planets in our solar system. As Space.com explains, the bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. This explanation has been the scientific consensus for decades, though recent research suggests more complexity to the story. While scientists have long known that iron oxide causes the red coloration, the specific type of iron oxide has been a subject of debate. Until recently, researchers believed the primary mineral responsible was hematite, a dry iron oxide that forms without water involvement. This understanding aligned with theories that suggested the oxidation occurred later in Mars's history, after its suspected wet period had ended. However, groundbreaking research published in February 2025 has challenged this view. Scientists now suggest that Mars's red color may be better matched by Ferrihydrite, a water containing iron oxide that typically forms rapidly in the presence of cool water. This discovery suggests the reddening process occurred during a period when water was still present on the Martian surface, rather than after Mars had dried up. The fact that this water signature has persisted even as the mineral was ground down and distributed across the planet provides an intriguing window into Mars's past conditions. Mars hasn't always worn its famous red coat. In its distant past, the planet is believed to have more closely resembled Earth, with substantial bodies of liquid water on its surface, a much thicker atmosphere, and active volcanic activity. The transformation into the rusty world we see today occurred through a series of geological and chemical processes spanning billions of years. Understanding how Mars became red requires examining both its planetary formation and subsequent environmental evolution. Mars's smaller size compared to Earth played a crucial role in its iron distribution. While the majority of Earth's iron sank to its core when our planet was young and molten, Mars's weaker gravity allowed more iron to remain in its upper layers. This abundance of iron in the Martian crust provided the necessary material for the subsequent oxidation process. As NASA scientists explain, though Mars does have an iron core, its smaller mass meant the planet remained less differentiated, with significant quantities of iron accessible in its surface layers. This set the stage for the planet-wide rusting that would eventually occur. The oxidation process that transformed Mars's surface involved complex interactions between iron and oxygen, much of which likely came from water. Evidence suggests that Mars once had substantial amounts of water, perhaps even oceans. The planet's lower mass and consequently weaker gravitational pull allowed water vapor to rise higher in the atmosphere, where ultraviolet radiation from the sun could split the water molecules into hydrogen and oxygen. The lightweight hydrogen atoms could escape into space, while the heavier oxygen remained and reacted with the iron-rich surface minerals. As explained by the Mars Society of Canada, oxygen is extremely reactive, particularly with iron-rich minerals on Mars' surface. This naturally led to the formation of iron oxide, similar to how Earth's banded iron formations were created when oxygen first emerged in our atmosphere. The result was the global distribution of iron oxide that gives Mars its characteristic color. The reddish dust that defines Mars's appearance isn't static. It's constantly in motion, reshaping the planet's surface. Over billions of years, the iron oxide material has been broken down into fine particles and transported across the planet by powerful Martian winds. This dynamic distribution system ensures that the rusty coloration extends across virtually the entire planet, creating the uniform appearance we observe from Earth. The weathering and erosion processes continue to this day, with Martian winds actively redistributing the dusty material across the planet's surface. Mars experiences dust storms that can grow to extraordinary proportions, sometimes engulfing the entire planet. These massive weather events play a significant role in enhancing and maintaining the planet's red appearance by suspending dust particles throughout the atmosphere. When these fine iron oxide particles become airborne, they scatter sunlight in ways that further emphasize the reddish hue. It's worth noting that while Mars appears distinctly red when viewed from Earth, spacecraft that have landed on the surface have revealed a more nuanced reality. According to the BBC Sky at Night magazine, if you could visit and spend a day on Mars, would you really see that the surface is bright red? The answer is that the surface appears more butterscotch in tone when viewed up close. This difference in perception highlights the complex interplay between the planet's surface materials, atmospheric conditions, and our observation perspective. The thin Martian atmosphere plays a surprisingly significant role in the planet's perceived color. Composed primarily of carbon dioxide, Mars's atmosphere is much less dense than Earth's and interacts with sunlight in distinctive ways. When sunlight penetrates this thin atmosphere, it undergoes Rayleigh scattering, the same phenomenon that makes Earth's sky appear blue. However, on Mars, this scattering causes shorter wavelengths of light, blue and green, to disperse more widely, allowing longer wavelengths, red and orange, to dominate the visual spectrum. This atmospheric effect enhances the reddish appearance of the surface below. The atmosphere itself also takes on a reddish hue due to the presence of suspended dust particles. The iron oxide particles are so fine that even in Mars's thin atmosphere, they can become lofted upward, adding their reddish color to the sky. This dual effect, red surface and reddish atmosphere, reinforces the planet's nickname. The atmospheric conditions on Mars thus play a crucial role in its overall appearance, working in conjunction with the surface composition to create the distinctive coloration we observe from Earth. The red appearance of Mars has inspired cultural and mythological associations throughout human history. Ancient civilizations typically named the planet based on its distinctive color, often associating it with blood, warfare, and death. The Romans named the planet after their god of war, Mars, following the precedent set by the ancient Greeks who named it after Ares, their war deity. These associations were directly inspired by the planet's blood-like coloration. Similarly, ancient Egyptian astronomers called it Her-Desher, meaning the red one, while Chinese astronomers referred to it as the fire star. In Babylonian astronomy, Mars was known as Nergal, after their god of death and pestilence, with its blood-like color reinforcing associations with mortality and disease. These historical connections between Mars's appearance and concepts of violence and mortality have persisted for millennia, demonstrating the profound impact the planet's visual characteristics have had on human culture and imagination. The endurance of these associations speaks to the visual power of the planet's distinctive coloration, which continues to capture attention and inspire wonder in the modern era. Mars earned its nickname, the Red Planet, through a complex interplay of geological processes, atmospheric conditions, and human perception. The planet's distinctive coloration primarily results from iron oxide in its regolith, formed through interactions between iron-rich surface materials and oxygen, much of which likely came from water that once existed on Mars. Recent research suggesting Ferrihydrite rather than hematite may be responsible for the red color could fundamentally change our understanding of when and how Mars transformed into the rusty world we see today. The planet's red appearance has left an indelible mark on human culture throughout history, inspiring connections to warfare and blood that persist in its nickname. As our scientific understanding of Mars continues to evolve, the mystery of its red appearance provides a window into the planet's past and offers valuable insights into its potential to have once harbored life.